a teaspoon of matter from a neutron star, heavier than the entire Mount Everest. A beam of light you see in the sky may have started its journey millions of years ago, and black holes, where the laws of physics break down, continue to silently devour everything, even light itself. The universe isn't the glittering fairy tale place we see in children's books. It's a realm where paradoxes become reality, where life as we know it is just one fragile possibility among millions of others. And yet, that's exactly what makes it so captivating, because every object out there, from planets, stars, and black holes to phenomena we've never fully verified, is telling part of a grand narrative, the story of where we live and perhaps of where we're going. So, sit down, look up, and listen as the universe tells its tale of gigantic galaxies, burning stars, mysterious planets, invisible black holes, and phenomena humans have only dared to imagine. Makes you wonder, what exactly am I living in? Is this all, or is there more? The universe isn't just stars and planets. It's a vast stage where every object, whether as massive as a galaxy or as tiny as a speck of cosmic dust, plays a role. In this journey, we'll explore the universe layer by layer, from spiraling galaxies, living and dying stars, to distant planets, icy moons, ancient asteroids, blazing comets, and even invisible black holes silently warping space and time. Each part, each story, will bring you closer to the great mystery of the cosmos. And now, let's begin this journey together. Galaxy, the home of the stars. You're drifting through space, no sound, no gravity. Before your eyes is a giant spiral, glowing with light. Each tiny dot is a star. Each star may have planets orbiting around it. That's a galaxy. And if you're looking at the Milky Way, then hello, that's your home. A galaxy is a vast collection of billions, even trillions of stars, planets, nebulae, dust, gas, and dark matter. They aren't calm, motionless clouds in the universe. They are enormous machines in motion, interacting and sometimes colliding. Let's begin with where we live, the Milky Way. Our galaxy is a spiral type, with at least 100 to 400 billion stars. It spans about 100,000 light years. That means light, the fastest thing we know, takes 100,000 years to travel across it. How small does that make us? We're located in a minor arm of the Milky Way, the Orion arm. Near the center lies a dense region of stars and dust, home to Sagittarius, A star, a supermassive black hole 4 million times heavier than the Sun. But don't worry, we're far enough to stay safe, for now. Look beyond the Milky Way, and you'll find hundreds of billions of other galaxies, each one with a different shape: spiral, elliptical, irregular. Some whirl like a storm, others blur like ink in the night. The closest galaxy to us is Andromeda, about 2.5 million light years away. Yes, you heard that right. Its light has been traveling for 2.5 million years just to reach your eyes. And here's the twist. The Milky Way and Andromeda are heading toward each other. Speed? Around 400,000 kilometers per hour. In about 4 billion years, they'll collide. But it won't be a violent crash. The distance between stars is so vast that the collision will be more like two clouds passing through one another. Millions of years later, a new galaxy may form, perhaps called Milky. Galaxies don't stand alone. They form galaxy clusters, bound together by gravity. The nearest major one is the Virgo cluster, and beyond that are superclusters like Laniakea, where even the Milky Way is just a dot on a cosmic map. Galaxies are more than collections of matter. They are living records of the universe's history. Each one carries the story of star birth, evolution, and death. By studying their shapes, motion, and structure, astronomers can trace how the universe has changed over billions of years. Galileo Galilei once said, "I saw thousands of stars where before there was only darkness." That moment, when he first looked at the Milky Way through a simple telescope, marked the beginning of a new era, when humanity no longer saw the sky as a ceiling, but as a doorway to the infinite. Today, with telescopes like Hubble and James Webb, we're seeing galaxies tens of billions of light years away, which means we're looking into the ancient past, when the universe was still young. And the next time you look up and see a faint glowing band across the night sky, it's not a cloud. It's the light of billions of stars in the Milky Way, a thin slice of a giant city of stars, the place you live in without even realizing it. So, next time you gaze into the night sky, remember, you're not just looking at the stars, you're looking home. Stars, the suns burning across the universe. Look up at the night sky and you're seeing the light of giant fireballs, burning non-stop for millions of years. They are stars, the suns of other worlds, and sometimes of our own. The most familiar star to us is the sun. It's close enough to shape all life on Earth: light, heat, weather, biological rhythms, even our emotions. But on the scale of the universe, the sun is quite ordinary. A yellow dwarf star, stable and relatively small. Beyond the sun, there are hundreds of billions of stars in the Milky Way, and trillions more in distant galaxies. They come in all shapes, sizes, ages, and temperaments. Some stars are hundreds of times bigger than the sun, blazing so brightly they can be seen from millions of light years away. Others are cold, dim, and smaller than Earth. One of the most stunning examples is Betelgeuse, a red supergiant in the constellation Orion. Its diameter is so massive that if placed in our solar system, it would engulf the orbit of Mars, maybe even reach Jupiter. But it's dying. At any moment in the next few 100,000 years, it could explode into a supernova. And if it happens in your lifetime, you'll see a new star in the sky, as bright as a second moon, lasting for weeks. Meanwhile, red dwarfs, the most common type of star in the universe, live very differently. They're small, cool, dim, but live incredibly long lives, hundreds of billions of years, far beyond the current age of the universe. Because of their stability, many scientists believe if life exists out there, it might orbit around a red dwarf rather than a massive star. When a massive star runs out of fuel, it explodes in a supernova, releasing light so intense it can outshine an entire galaxy. In those chaotic seconds, heavy elements are born. Gold, silver, uranium, all the things we consider precious were forged in the death of stars. As Carl Sagan said, "We are made of star stuff." That's not a metaphor, it's basic chemistry. After death, some stars leave behind a dense core, a neutron star. These bizarre objects are so heavy that a single teaspoon of their material could weigh over 1 billion tons. If they spin rapidly, they emit radio waves, known as pulsars. And if the mass is great enough, they collapse further into black holes, places where not even light can escape. But not all stars end in tragedy. A star like our sun, when it runs out of fuel, will expand into a red giant, then shed its outer layers into a beautiful nebula, leaving behind a small white core, a white dwarf, that cools slowly over time. Stars aren't just lonely fireballs. They can come in pairs, binary systems, or in clusters where millions of stars are born together. Globular clusters like 47 Tucanae are cosmic wonders, hundreds of thousands of stars crammed into a space just dozens of light years wide. Stars are also the birthplaces of planets. In the swirling clouds of gas and dust around young stars, matter clumps together to form planets, moons, and asteroids. That means every star out there has the potential to host its own solar system, with its own worlds, its own climates, its own stories. Telescopes like Kepler have discovered thousands of exoplanets in just a few years. Some lie in the habitable zone, where liquid water could exist. And since most stars have planets, the idea of life beyond Earth is no longer science fiction. It's a probability waiting to be explored. Stars, the suns burning across the universe, are not just sources of light. They are the origin of life, of death, and of everything we can touch in the cosmos. And if one night you see a star suddenly fade away, remember, you've just witnessed the end of a story that lasted millions of years, all in the blink of an eye. Planets, the gems that orbit the stars. The word planet may sound familiar. After all, we live on one. But Earth is just a tiny piece in the grand puzzle of worlds out there. In the universe, planets are non-luminous celestial bodies, orbiting stars, like gems circling blazing flames. In our solar system, we have 8 major planets. Each one isn't just different in size or color, but an entirely distinct world with its own climate, history, structure, and even potential for life. Mercury, the closest to the sun, is a world of burning days and freezing nights. With no thick atmosphere to hold in heat, the temperature difference between day and night can reach hundreds of degrees. Venus, Earth's twin in size, is a true hell. Its atmospheric pressure is 90 times that of Earth, and its thick CO, two clouds create a runaway greenhouse effect, keeping its surface hot enough to melt lead. Earth, the only planet we know for sure, harbors life. It has liquid water, an oxygen-rich atmosphere, a protective magnetic field, and the perfect position around the sun. But the next planet, Mars, has captured our imagination like no other. Thin air, dry soil, frozen poles, and signs that rivers and lakes once flowed across its surface. Massive dust storms cover the planet, but none of it deters humanity's desire to one day set foot on it. Farther out lies Jupiter, the largest planet in our solar system. A gas giant with no solid surface, Jupiter boasts the strongest magnetic field and the largest storm, the Great Red Spot, which has raged for centuries. Saturn, equally captivating, is famous for its stunning rings made of ice and rock, spinning like a shimmering cosmic halo. Keep going, and you'll find Uranus and Neptune, the icy giants, cold, distant, and full of mystery. Winds on Neptune can reach up to 2,000 kilometers per hour, the fastest in the solar system. And beneath its blue clouds, perhaps an ocean of superfluid? We still don't know for sure. Our solar system is just one of billions of planetary systems. Thanks to telescopes like Kepler and TESS, we've discovered thousands of exoplanets, planets beyond our solar neighborhood. Many of them are Earth-sized, and some lie within the habitable zone, where temperatures allow liquid water to exist. There are giant rogue planets drifting freely, untethered to any star, nomadic worlds. Some orbit their stars so closely that their entire year lasts just a few Earth days. Others are covered in oceans hundreds of kilometers deep, or possess atmospheres of mercury, ammonia, even flying glass. We're not just searching for Earth-like places, we're also trying to understand what makes Earth so special. Because to understand planets is to understand ourselves. Each planet is a story, a chapter in the vast book of the universe. Some we've already read, others are still waiting to be discovered. So, if you could set foot on another planet, which one would you choose? Satellites, the silent companions. When we talk about the universe, we often think of brilliant stars, massive planets, or mysterious black holes. But hidden in the shadows, quietly orbiting planets, are satellites. They're not flashy or radiant, yet they're the silent companions that play a vital role in the balance and operation of planetary systems. Satellites come in two types, natural and artificial. Natural satellites are non-luminous celestial bodies held in orbit by a planet's gravity. The Moon is Earth's only natural satellite, but far from the only one in our solar system. In fact, over 200 natural satellites have been discovered, and more are being found each year. The Moon isn't just a beautiful sight in the night sky. It has a deep impact on life on Earth, from controlling tides to stabilizing the planet's axial tilt. Without it, Earth's climate might have been far more chaotic, and life as we know it might never have evolved. Beyond Earth, we encounter Titan, Saturn's largest moon. It has a thick atmosphere, a rare feature among moons, and lakes and rivers made of liquid methane. With its cold yet stable climate, Titan is a prime candidate for NASA's exploration missions, potentially holding the ingredients for life, or at least prebiotic chemistry. Europa, one of Jupiter's icy moons, is covered in a shell of ice. Beneath it lies a vast underground ocean, possibly tens of kilometers deep. Many scientists believe that if extraterrestrial life exists somewhere in our solar system, Europa's hidden ocean is one of the best hopes, much like the deep, sunless oceans on Earth, where hydrothermal vents support thriving ecosystems. Ganymede, the largest moon in the solar system, even bigger than Mercury, has its own magnetic field and may also harbor a subsurface ocean. Callisto, Enceladus, Miranda. Each moon is a miniature world with its own unique features. While planets often steal the spotlight, moons may be the more accessible stepping stones for human space exploration. Establishing research stations on the moon could pave the way for deeper journeys into space. Future missions may find it more practical to build bases on moons rather than planets, due to their lower gravity and more stable conditions. Beyond natural moons, humanity has launched thousands of artificial satellites orbiting Earth, serving communication, observation, navigation, and even weather forecasting. The International Space Station, ISS, is a remarkable example. A manned satellite where humans live and work in orbit for extended periods. These man-made satellites form a vast, invisible web encircling the planet, each one a crucial part of the modern world's connectivity. Satellites aren't just lifeless rocks circling their planets. They're vital pieces of the cosmic puzzle, revealing the diversity and complexity of our universe. Each one tells a story. Some bear the scars of ancient asteroid impacts. Some are frozen worlds, drifting in silence for billions of years without change. And sometimes, it's in that very silence that we find the clearest clues about life, about the solar system's past, and about our own future. But the universe isn't just filled with massive, brilliant objects. Sometimes, it's the small, the cold, and the invisible that hold the key to understanding where it all began, and where it's going. In the next episode, we'll journey into the darker corners of the universe, where ancient remnants drift silently, black holes devour light, brilliant nebulas blaze, and mysterious phenomena remain unproven. Don't miss Part 2. Secrets hidden in the shadows, as we continue our voyage across the cosmos. And if you found this journey fascinating, don't forget to like this video, subscribe to the channel, and turn on the notification bell, so you won't miss any of the awe-inspiring episodes in this cosmic series.